So recently, a friend of mine posted this number puzzle on Facebook. There's a 3-digit combination lock, and someone has given us these 5 clues to help us figure out what the combination is. I want to take a look at one way that we could work through figuring out this puzzle. So this puzzle gives us 5 sample numbers and compares them to the final answer that will open the combination lock. The clues, or the rules as I'll call them, talk about the digits of the sample numbers being right or wrong and whether they're in the right or wrong place. Let's take a look at these rules one by one. The first rule tells us that from the number 682, one digit is right and in its place. The second rule tells us that from the number 614, one digit is right, but it's in the wrong place. The third rule tells us that from the number 206, 2 of the digits are right, but they're both in the wrong place. The fourth rule tells us that from the number 738, all of the digits are wrong. And finally, the fifth rule tells us that from the number 380, one digit is right, but it's in the wrong place. So one useful thing that we can say is that most of these rules are really 2 rules in one. The first part of each rule tells us about what the digits are, and the second part of each rule tells us about where they go. It's pretty common in logic puzzles that part of what makes them difficult is that you get so much information thrown at you that you don't know what to think about first. So it's useful to recognize that these rules actually have 2 different kinds of information written in one sentence. So let's start by just considering the information about the digits and worry about where they might go later. So instead of trying to figure out what the final answer is right away, we can start by asking the smaller question, what numbers will make up the digits of the answer? So for instance, if we figure out that the numbers will be 1, 2, and 3, that means that the answer could be 1, 2, 3, or it could be 1, 3, 2, or any number that uses those 4 digits. So answering this smaller question won't give us the answer right away, but it will help us narrow down pretty significantly what the answer could be. So now that we've decided what smaller question we want to try to answer first, next we should decide which of the 5 rules gives us the biggest boost towards answering that question. If we take a look at the first rule, we can see that it gives us information about one of the digits of the number 682. One of those digits is right, which means it's part of our final answer. And that's useful information, but it's not enough to work with yet because that one digit that's right could be 6, or it could be 8, or it could be 2. So let's see if we can do better than that. The second rule tells us about a different number, but still only one of its digits. The third rule is a little bit better. It tells us about 2 of its digits, but we still can't be sure which digit isn't right. The fifth rule also only tells us about one digit, but the fourth rule tells us something about all of the digits of its number. So right away, it's our favorite rule. But actually, it tells us something different from the other rules. It tells us that all of the digits are wrong. Another way of saying this is to say that none of these numbers will make up the digits of the answer. So 7 won't be anywhere in the answer, 3 won't be anywhere in the answer, and 8 won't be anywhere in the answer. We know that for sure without having to do any guessing. We figured out a concrete piece of information. Although it doesn't seem particularly helpful at first, there are still a lot of numbers that don't have a 7 or a 3 or an 8 in them. That's actually a fun bonus puzzle for you. How many 3-digit numbers don't have a 7, a 3, and an 8 in them? But a great trick to solving logic puzzles now that we have concrete information is to go back to the other rules and to see if we can use what we've learned to make those other rules more helpful to us. Well, if we start by going back to the first rule, we notice that one of the digits that we now know won't be part of our answer is also part of this rule's number. 8 is the tens digit of this number. So what does this mean? It means that we can cross out the 8 as far as this part of the rule is concerned. One digit of this number is right, but we know that it can't be the 8 because we just figured out that 8 can't be one of the digits of the final answer because it's part of the number 738. So this is good progress. We still don't know whether it's the 6 or the 2 that's right, but we definitely know that it isn't the 8. So let's see if we can do the same with the other rules. If we look at the second rule, there's not a lot that we can do here. There isn't a 7 or a 3 or an 8 in this number. Same thing with the third rule. But if we go to the last rule, here we can definitely apply our new knowledge. First things first, 380 has a 3 in it, so we can cross that out. And it also has an 8 in it, so we can cross that out too. But wait a minute, there's only one digit left, which is great news because the rule is exactly about one digit. So this rule can only be referring to the 0 that's left standing. So when this rule says that one digit is right, that one digit is 0. 0 is right. So now we have a new concrete piece of information that we know without guessing, and that is that 0 has to be one of the numbers that makes up the digits of the answer. So now that we have a new piece of information, let's do exactly what we did the last time we had a new piece of information, and let's see if we can use it to make any of the rules more useful to us. Well, what we just figured out is about the digit 0, and there's only one other rule that has a 0 in it, and it says that two of the digits in the number 206 are right. But now we know that one of those two digits that are right is 0. So we can rewrite this rule to something a little more specific. We can stop worrying about the 0. And instead of saying that two of the digits 2, 0, and 6 are right, now we can say that one of the digits 2 and 6 are right because we already know the 0. And actually, if we take a look at the first rule, we can see that this is the same thing that the first rule is telling us. We crossed out the 8 here because we know that it can't be one of the digits. Whereas in the third rule, we cross the 0 out because we know that it has to be one of the digits, but the effect is actually the same. As far as the numbers that will make up the digits of the answer, these rules are both telling us that one of the numbers 2 and 6 will be included. Now you may have noticed that the second rule also has a 6 in it, and it also says that one digit is right. And you may be asking, does this mean that 6 has to be the digit that's right? Because the first three rules all say that one digit is right, and they all have a 6 as one of their digits. And that's a good observation, and 6 absolutely could be one of those digits, but it might also not. For instance, the first and the third rules could really be about 2, and the second rule could really be about 1 or 4, and these combinations would still satisfy all of the rules. So we don't have enough information to say without guessing that 6 is a digit as well, but it may be useful later to remember that 3 of the rules are all about the number 6. So it seems like we figured out all of the concrete information that we can write down without guessing by looking just at this part of the problem, the part where we just look at what the digits are and we're not worrying about where they go. But there's a little more that we can say while we're here, even if it's not entirely definitive. By looking at the first and third rules, we can say that in addition to 0, which must appear in the final answer, either 2 or 6 must also appear in the final answer. We know this because if neither 2 or 6 appeared in the final answer, it would break the first and the third rules. And by looking at the second rule, we can also say that one of the numbers 1, 4, or 6 must appear in the answer. And again, that's exactly one of those numbers, not 0 or 2 or 3 of them. Okay, so we've made some statements about what numbers must appear in the final answer. Now let's take this information forward with us and reintroduce the information about digit placement to see if we can make any conclusions about where these numbers have to appear. And remember, just like how the fourth rule didn't seem like it was that helpful at first until we applied that limited information to the other rules, it's okay that we haven't completely figured out what numbers might appear in the final solution. So we're back to where we started. And before we start working, we can make some room, as we can see from the fourth rule. This rule doesn't have a statement about where the digits go, and it doesn't actually need one, since it only talks about digits that aren't in the final number. So we can actually toss this rule aside, since we've already used all of its information to decide on what we wrote at the top of the screen. So now we've just got 4 rules, but still the same question. Which one do we start with first? Let's start at the top. So this rule says that one digit is right and in its place, its correct position in the final number. But that's not quite enough to say anything with yet because we know that 6 could be one of the final digits, but also 2 could be one of the final digits. The number could start with a 6 or it could end with a 2. We don't have a good way of knowing which yet, so let's keep looking. Similarly, the second rule says that one digit has to match, but this rule is even less helpful for now because 6 is a valid digit, and so is 1, and so is 4. So let's move on for now. Now this rule is different, but it actually has the same problem because even though it's about 2 digits rather than just 1, all 3 of this number's digits could be in the final number. So our hopes are pinned on the fourth rule telling us something. Now it's about one digit as well, but this time only the 0 is a valid digit from the number 380. The 3 is a digit that we already ruled out, and so is the 8. So what does this mean? Well, let's think about a template of what the final answer might look like. Let's lay out 3 blanks for the final number, just like we're playing hangman. Now what can we say about where the 0 could go? This rule says that 0 is in the wrong place in the number 380, and it's in the ones place. So our template could look like this. The 0 could be in the hundreds place, or it could be in the tens place, but it definitely can't be in the ones place because that's where it is in the number 380, and that's the wrong place. So that's no good. So let's write down our 2 valid templates for the final number. In the first template, the 0 was in the hundreds place, and in the second template, it was in the tens place. That's all we can say based on the fourth rule, but it is new information. So in what is probably a familiar tune by now, let's take this information and go back to the rest of the rules and see if we can get any more new information. So if we work back upwards, starting with the third rule, it tells us that 2 of the digits in the number 206 are right, and we know from before that one of those digits is 0. So let's write that down just to make sure we don't forget. So when we say 2 of the digits are right, part of what we're saying is that 0 is right. But the same is true for the other half of the sentence too. When we say that both digits are in the wrong place, we're saying that 0 is in the wrong place. This seems obvious, but if we look back at our templates, we can see that 0 is in the tens place in the number 206, but the rule says that that's the wrong place. And our second template has 0 in the tens place, so this is wrong. We can rule out one of our templates. But since we said while looking at the fourth rule that one or the other of these templates has to apply, this means that we've just made another discovery. Not only can we say that 0 has to be in the final answer, but now we can say that 0 has to be the first digit of the final answer. So we're 1/3 of the way to our final answer. But to look at it a little more optimistically, there are 1,000 3-digit numbers, but there are only 100 3-digit numbers that start with 0. So we started with 1,000 possibilities, and now we have 100. We're 90% done. Now let's see if we can get through the last 10% by using our new knowledge, combined with this rule to make even better templates for what the final answer might be. So the 0 is definitely right, which means that from the number 206, one of the other 2 digits could be. So if it's the 2, that means that the 2 has to be in the wrong place in the number 206. That means it could either be in the tens place or it could be in the ones place. These templates both follow the rule because in both templates, 2 digits are right, 0 and 2, and neither are in the same place as in the number 206. But it's also possible that the 6 is the other digit that's right, not the 2. In that case, the 6 can't go in the ones digit of the final answer because that's where it already is in the number 206. And it can't go in the hundreds place because that's where 0 already has to be. So for 6 being the correct digit, there's only one possible template, and that's that 6 belongs in the tens place. Now, since our templates have 6s and 2s in them, a natural next place to look for information might be to go back to the first rule, which also has 6 and 2 in it. The first rule tells us that one digit is right and in the right place, and because we know from the very first rule we looked at that 8 can't be one of the digits of the final answer, we know that the one digit this rule is talking about must either be the 6 or the 2. But there's a problem with the 6 being that digit. What's the problem? The problem is the location text that we introduced back into the rule, that this digit must be in the right place. This is a problem because the 6 is in the hundreds place in the number 682, but we've already figured out that 0 has to be in the hundreds place of the final answer. So this means that 2 has to be that digit that is correct and is in the correct place. So this tells us that we can cross out this template because this template has the 2 in the tens place. But also we can cross out this template. Now why is that? Because in the information that we figured out about the digits earlier, we said that either 2 or 6 could be part of the final answer, but not both. So not only do we know that 2 has to be in the ones place of the final answer, we also know that 6 cannot appear in the final answer at all. So let's go ahead and write the most specific template that we have under this first rule, just so we can remember that this rule helped us confirm that template. And we can keep applying this new information that 6 can't be in the final answer to continue to refine what we figured out earlier about the digits that can be part of the final answer. specifically this part, which mentions 6 not once, but twice. We can start by crossing out either 2 or 6 and replacing this with just 2. We know that 2 has to be part of the number. This is pretty obvious because we even figured out that it has to be in the ones place. But we can also cross out one of 1, 4, or 6, and we can refine that down to either 1 or 4. Since we knew before that 1, 4, or 6 had to be in the answer, and now we know 6 can't be, that means that either 1 or 4 has to be. So here's our new refined knowledge about the numbers that can make up the digits of the final answer. 0 has to be in the answer, and we know that it will be in the hundreds place. 2 has to be in the answer, and we know that it will be in the ones place. And either 1 or 4 has to be in the answer. And since there's only one place left for 1 or 4 to go, it'll have to be in the tens place. So now, out of all possible 3-digit numbers, we know that our 2 remaining candidates will look like this. Either there will be a 1 in the tens place, so the answer will be 0, 1, 2, or there will be a 4 in the tens place, so the answer will be 0, 4, 2. And this naturally leads us back to the second rule, which is about 1s and 4s. Only one of these digits can be right, and since we know 6 can't be in the final answer, the digit that's right has to either be 1 or 4. But here again, the placement information is what gives us the final piece of information that we need. Not only does 1 or 4 have to be the digit that's right, but it also has to be in the wrong place. Now, do you see the problem with that digit being 1? It's in the same place in the number 614 and in our candidate number that has a 1, 0, 1, 2. It's in the tens place in both answers. So if the 1 has to be in the wrong place, and it's in the tens place in 614, it can't be in the tens place in 0, 1, 2. So the digit that's right, but in the wrong place, has to be 4, which means that we can cross out our final remaining false candidate. Now we have just one possible answer remaining, 0, 4, 2. So how did we get here? By breaking down the wall of information the puzzle presented us with into smaller pieces of information and considering each piece and reconsidering each piece, figuring out small bits of information that seemed unhelpful at first until we re-examined what they could tell us about other pieces of information. But to be really sure that this is the answer, let's run it past that original wall of information to make sure that we're definitely right. So here's the original puzzle, just as we started with it before we broke it down and started looking at single rules or single parts of rules or digits or placement or anything. So let's see if 042 works as an answer. The first rule says that one digit of the number 682 is right, and only one digit. And that digit is in its place, and sure enough, the 2 is right. 6 and 8 both don't appear in 042, and the 2 is in the right place. Good. The second rule tells us that one digit of the number 614 is right, but it's in the wrong place. Yep, the 4 matches while the 6 and the 1 don't, and the 4 isn't in the same place in 614 and 042. Good. The third rule tells us that 2 digits from the number 206 must be right, and they must both be in the wrong place. Good here too. The 2 and the 0 match while the 6 doesn't, and both the 2 and the 0 aren't in the same place in 206 and 042. This rule works too. The fourth rule, our original favorite rule, says that all of the digits of 738 can't be in the final answer. Yep, no problems there. And finally, the last rule tells us that only one digit in the number 380 is right, and it's in the wrong place. And sure enough, only the 0 matches, and it's in the wrong place in the number 380. So the final rule matches too. So all of the original rules work with the number 042. It's definitely a number that works. And as we figured out along the way, it's also definitely the only number that can work. So what did we do to get here? Well, at first glance, it might just seem like a silly puzzle about numbers and digits, and if you really had a 3-digit combination lock in front of you, you'd probably be pretty frustrated if this kind of riddle is how someone told you what the combination is. But the reason that I like this puzzle is that we applied really solid and important principles of problem solving in order to get to the final answer. It wasn't the premise that made the puzzle interesting, but the challenge of the process that we had to apply. And what was that process? Well, first, we broke the 5 rules we were given into smaller pieces of information. The rules told us 2 things: what digits can be in the final answer and where do those digits go. Then we used those smaller pieces of information to start by solving a smaller problem, when we threw away the placement information and just dove into the digit information to see what we could figure out about the digits, rather than trying to solve the whole thing at once. Then we got our first concrete piece of information as a gimme, that 3 digits couldn't be in the final answer. At first, that information didn't seem like it helped us at all, but we used it to narrow down options for some of the other pieces of information that we knew would help us more, even if what they were telling us wasn't so obvious at first. Then, once we went over the rules and we went over them again, to get as much information from that smaller problem as we could, we worked back up to the bigger problem, introducing all of the information that we were given at the start, and we were okay with the fact that we hadn't completely solved the smaller problem of just what numbers could make up the digits of the final answer, considering the smaller problem had still given us all of the extra information that we needed to solve the bigger problem. And hopefully in doing so, we had fun. At least I know that I did, and I hope you did too. Thanks for joining me.